Hey guys, let's see if we can wrap up this humidifier in this segment. Thanks for all your tips and suggestions and theories. What I ended up doing was ordering a new 12-volt regulator, and as was suggested, I got a beefy version. So this is 2.0 amps. The typical standard one is rated for 1.5 amps, and I think maybe some cheapo versions only 1 amp. Well, this is a name brand ST Micro rated for 2 amps, so that's what I'm going to use. So as for why it burned out, the more I think about it, look at the circuit, I really don't think it was heat. There's not a whole lot of current draw, and that's probably why they didn't use heat sinks. I think what's far more likely is that it was a voltage surge. There's really no protection in this whatsoever. And with the relays clicking and the compressor turning on and off and blower motor, there's going to be some spikes. And there's no transient suppressant circuit on this, and there's also no reverse voltage protection. They usually put a diode across the voltage regulator. It might be built into this one. I'll take a look at the application notes. But what can happen is if there's some induced back voltage on the output voltage can exceed the input voltage, and that could cause trouble. Or what I think is more likely is there was a surge on the transformer, or possibly from one of the relays, which also have some protection diodes across them. And the other thing that's also very, very likely is this is a really cheap, no-name, or well, a cheap brand voltage regulator. And I didn't notice this in the first video. You couldn't put a heat sink on there, so it wouldn't do you much good because this thing is completely plastic encased. There is no metal tab on it at all. So nowhere for the heat to go. I'll pop one of these out. Well, you can see the difference already, even through the packaging. That has metal. So even without a heat sink, this has got some metal to dissipate the heat, whereas this has nothing. Maybe there's some metal underneath that plastic, but the plastic will certainly act as an insulator and reduce the heat transfer. So I'm going to pop one of these guys in, remove this stuff that I put in there, and let's see how it works. Oh, also wanted to mention that I picked up a few other parts while I was at it. For an upcoming project, I will be getting back to TVs soon. I've got a couple TVs for a client. He's been waiting patiently for quite a while now. One of them is a brand you've seen me work on many times, but this is a newer set than I've worked on by this particular brand, and it's a different design, and I'll get to break out some of that test equipment I showed recently. And the other one is a brand I've also worked on before, and this is a model I've talked about a little bit, shown you guys, but have never worked on before. And these 4 capacitors are a little hint as to what model that may be. These are 4 150 microfarad, 250 volt capacitors. I did a little research on the internet, dug up some application data sheets for the 7800 series of voltage regulators, and found some protection ideas. So this is kind of the standard layout, where you got voltage in, regulated voltage out, and the third terminal is grounded. I recommend in some applications you may want to add some extra capacitance here. This one, if the regulator is a bit far from the bridge rectifier and main filter cap, doesn't really apply. And this circuit, because the bridge rectifier is right next to it. This capacitor can help with the transient response on the outputs, especially if you have heavy loads switching in and out. And this diode is something you might want to add if you have heavy capacitance load. Because what can happen is if you turn off the main power here, you can end up in a situation where you've got higher voltage on the output than the input. Well, this will shunt that around the regulator to protect it. So that's something I could add. And these are some other ideas more general to all types of power supplies. So just a kind of a generic schematic here where we've got 120 volts AC in. This would be your line voltage in. Fuse. One thing you can add is a MOV, metal oxide varistor. It's a variable resistor that goes right across the line, and these will come rated for like 130 volts, 150 volts, 230 volts. What these are is these are voltage dependent resistors. High resistance unless the voltage exceeds their threshold, and they start conducting more, and that will short out the transient. Now these can only handle so much power, so they're meant for very short durations of pulses, like there's a lightning strike or something on the primary line. This will absorb it. On the secondary side, something you can add, something I showed in a recent restoration of a Motorola VT71, is a TVS diode, which is sort of like back-to-back Zener diodes, which will clamp the secondary voltage. So this thing has around 20 volts AC unloaded, so I could maybe get like 25 volt TVS diodes, something like that. So that these would short out the secondary if there's any transients that exceed their threshold voltage. Again, these can only handle so much power, so they're only meant for short duration. And here's your standard bridge rectifier and regulator, and so on. So these are some possibilities. So suppress transients on the primary side, suppress transients on the secondary side, and add a protection diode in case the voltage on the output exceeds the voltage on the input. There is the new voltage regulator in place, and I cleaned up everything down below. So I got a few options now. I could install some protection circuitry, could replace some capacitors, but what I'm inclined to do is just try using it as is. Here's my rationale. Got this for nothing. Had some fun troubleshooting it. Think I found the problem. Thing's only a couple years old. I just spent a couple bucks on a new part. This thing ran great all last summer. Why not give it a try just as is? If it has a problem again, I have a pretty good idea what it will be. I bought 2 of those regulators, so if this new one fails anytime soon, I will investigate further. But for now, I'm just going to put this board back in place, plug it in, and see how it works. Okay, it's plugged in. Everything seems to be working as it should. I'll let this go for a while. See if the compressor kicks in, and that's good. It's actually not that humid right now. Yeah, everything seems to be running just fine. Yeah, everything seems to be working just fine. Compressor's been running for a while now. It's a bit warm. Let's see if we've got any. That's good. It's supposed to turn off when you pull this out. And yep, we've got condensation. Cool. So I know not the most exciting project, but hey, needed to get done. So I hope you enjoyed this little look at repairing a Kenmore KM50 dehumidifier. And one last look, I wanted to give you guys an update. This has been running about 2 weeks. It's been really hot and humid. This has been working like a champ. Very successful repair. I'm happy. Hope you guys enjoyed this series.